Hello, embedded engineers and developers. We are here at Embedded World 2025 talking to some of the most exciting companies and seeing some of the most exciting technology anywhere in the embedded space. I'm very happy to be here in the Sapphire booth with Simon George of AMD. We're going to talk a little bit about Embedded Plus. Simon, tell us everything about Embedded Plus. You have 2.5 minutes.
Excellent. Well, thank you for the moment. So again, hi, Simon George. I run embedded software engineering here at AMD, focused on embedded products. Today here, what we're showcasing is a really good collaboration with Sapphire Technologies, where we've collaborated on building a new hardware platform. But before I show you the answer, I want to show you on why we've done this and how we got there. What you see here is a demonstration of a heterogeneous software stack. As you can see here, we physically have 2 boards today. Both boards are hosting AMD SoCs, but it is physically 2 boards. On the right here, we have a Sapphire platform showing the V2000 APU, which is an x86 CPU with integrated graphics. We physically have a separate board here showing the Versal device. This is again an ASOC. It has integrated Cortex-A and Cortex-R compute. By definition, software running here, software running here. The 2 systems talk to one another over PCIe. As heterogeneous systems develop, it's very important to have portable software across the compute instances. So for this particular demonstration, what we're actually showing is CAN traffic being generated here. It's being generated across the CAN interface connected to the Cortex-R5 subsystem running on the Versal platform. Specifically, this is a VEK280 platform. That CAN traffic is using DDS as a communication infrastructure to come across to the second compute instance on this platform, which is focused on using the A72. That DDS information, which is transporting the CAN traffic, then comes across PCIe to the x86 platform. You can prove that by actually following the software workbench that we're showing on this display. How can I prove that as well? If you actually study the hardware platform, there is only a PCIe connection connecting these 2 systems. There is no network connection. Okay, that's a very important fact of this architecture. As powerful as this is, let's be honest, it's quite a messy bit of hardware here, okay? So where does the Sapphire collaboration come in? Well, actually, we've been working really closely with the Sapphire team, and just at this show, we've introduced the 5050A. So this is the VPR 5050A platform. Underneath this heatsink and fan, we have the 2 devices that I spoke about on this other hardware platform. So now, in a very convenient, very compact mini ITX form factor, you're actually going to be able to run the very same software stack. But again, commercially available, integrated form factor, showing all of the compute capabilities of the other platform, but obviously much more consolidated, which is why the collaboration with Sapphire is so important.
So, beautiful piece of kit. The hardware really is streamlined and consolidated, you know, moving from the concept here into execution.
Yes.
Talk to me a little bit about the software and the stack there, because you mentioned it a couple of times. How does that play in?
Sure, absolutely. So, you know, this is not just a collaboration that we've done directly with Sapphire. Really, for me, this is a community platform that we want developers to get hold of, to your earlier point. So we've also been working really closely with the upstream community, the Linaro team. As I said, 3 compute subsystems, 2 chips, okay? What we wanted to do was introduce a seamless ability to talk between those compute subsystems. So at a physical level, on the x86 V2000 device and the Cortex-A72, both of them are running the Zen hypervisor. We've been working really closely with the Linaro team to develop VirtIO Net over PCIe. So like I said, the big ribbon cable that is actually buried as electrical connections on this platform. And with that software stack that is going to be available open source, any developer is going to be able to directly develop on this platform, running real-time operating systems on the Cortex-R5, running guests on Zen, In this particular case, we have run Linux as guests on both the A72 and the x86 platform. So again, an open source development environment on a generally available platform. Again, very capable bringing together Cortex-A, Cortex-R, and x86 compute.
Spectacular. Thank you so much, Simon, for talking us through it.
Great,
Folks,
thank you.
don't go anywhere. Lots more to come from Embedded World 2025. I've been Ken Briodagh, your Editor-in-Chief for Embedded Computing Design, and we'll catch you on the next one.